Thank you, Sylvain. So good, still good evening, everyone. So we're going to be doing a workshop on attack surface discovery with OSINT. So we've got a bunch of tools we're going to be using. I've got another slide with a list of tools. But I have prepared some stuff to try and make it easier for some people. So basically what I've got is those two links. One's an AMD 64 VM. You could start downloading it now if possible. I've also got two USB keys here with the same stuff on. If you've got a MacBook with an AMD processor, with an ARM processor, then you're just going to have to install the dependencies that I'll show on the screen in a minute. Those are just links to Google Drives. There's nothing, well, I mean, you're just going to have to trust me, right? Okay. If anyone wants the USB keys, they're just here. Just come and grab one. Okay. I'll put those back on in a minute. I'm just going to introduce myself and stuff. So I'm James ATACK. Sylvain said I work for ONYPHE. ONYPHE is a cyber defense search engine. So we're in the same space as Shodan or Census, but we're slightly different. We scan URLs as well. We have historical data. And part of what I do as my day job is helping new customers or helping old customers. There you go. Find their stuff on the internet. We have a bunch of slides that we say where it's kind of provocative, but it says attack surface management is easy, but attack surface discovery is hard. Basically, once you know where all your stuff is on the internet, it's quite easy to scan that, to find where vulnerabilities are. But the hard bit for most organizations is actually finding their stuff on the internet. So I'll come back to this in a minute. So what we're going to look at tonight is a repeatable process for finding stuff on the internet. And it could be because you're a pen tester and you've got a new gig and you're trying to scope out a customer. It could be because you're on a SOC team and you want to try and defend a network and you're trying to make sure that the developers haven't put some crappy software on the internet. So we're going to work through using different tools, but beyond the tools, this is actually about having a kind of repeatable process which you can bring to any target and work out, and get a list of host names, a list of FQDNs, which you can then use to do, whatever scanning tool or whatever techniques you want for either defending or attacking. How is the VM downloading like super slowly, or is it gonna? Okay, I thought that might happen, but look, if necessary, we've got an hour and a half. If necessary, we'll install the dependencies together. I'll put up a shell, and we'll just work through it together. It'll be fine. There's still one USB key if somebody wants the VM. You could save yourself some pain, but maybe you like pain. Some definitions. So for this workshop, I'm going to use these terms. So the TLD, here you go. Cheers. TLD is top-level domain, of course. And TLD is not just the last bit of the domain, because it's basically where's the registrar that's providing the domain names. So co.uk is a TLD, gouv.fr is a TLD. And it's really important because we're looking at creating an inventory of first level domains, or FLDs. So when I say domain, I mean the first level domain. If I say hostname, FQDN, or subdomains, it's something below that. Okay? Yeah, okay. I hope that's all clear. Let me just go back to, okay, the requirements. Okay, so what we're going to be, so this text file here is actually, the notes in it are in French, but that might be convenient for some of you. The slides are going to be in English. Those notes are in French. The PDF, so that PDF has got all my slides, and it's got the links to the dependencies, so you might want to grab that as well. I'll just leave that for another 10 seconds. Okay. Let's go. So a repeatable passive process. What I'm going to do is, because I'm in like, I've got like 2 screens configured here. I'm just going to go to like a mirror. That's going to be a lot easier. Okay, is that going to work? Very good. It's going to save us a lot of pain. Right. So the VM, if you've managed to get the VM, the password is ONYPHE lowercase. It's just a bit of free marketing. Okay. Is that clear? Is that big enough? All those who think it should be bigger? No, one. Okay. Okay, I'll make it one more bit. There we go. Is that good? Okay. I'm going to be, hang on. How can I do this? I'm just going to put the PDF on this screen so that I can, I should have thought this through more, shouldn't I? Apologies for the slow start. We'll get going in a sec. Right. We're good. Right. What we're going to start with, so we're going to start with some curl, and we're going to start with crt.sh. I'm going to have to bring up the PDF here. It's the only way it's going to work, really. Okay. Okay, so we're going to start off with one domain name. So in my example, it's jackdaniels.com. Okay, the idea is that you've got an organization that you're trying to scope, and you can start off with their corporate domain name. So I know I've obviously done this one before, so I know what it's going to do. You can choose this one, or you can choose another organization. Thank you. My tip would be not to go for something too small and not to go for something too big. So you want an organization, like if you try and do this on like Total or like PepsiCo or something, then you will just never get to the end. I did try to do PepsiCo once. I think I gave up at 2,000 domains. So that's first level domain names. So yeah, just choose your target carefully. So what we're going to do is we're going to do a simple curl request to crt.sh. So certificate transparency logs, I think everybody knows what those are, but just very quickly in case people are discovering this. So certificate transparency logs are provided by certificate authorities, and the idea was to stop abuse of certificate authorities, because a certificate authority that is malicious could emit a certificate for google.com, and all the browsers are going to trust it, and then that could be used to intercept legitimate traffic. And the idea was, well, if all the certificate authorities have to publish their list of certificates, and it's a kind of signed chain of events, then that should avoid bad stuff happening. So certificate transparency logs are great as a starting point for asset attack surface discovery, because usually there's a human behind it. Usually requesting certificates, or at least filling in the forms, filling in even if it's DevOps, there's going to be some point where a human has typed in an organization name. So the first step here is saying, well, can we use CTLs and produce and try and find some subject organization names so that we can then pivot on that data point and find some other domain names. So if I take this, I'll show you what it's going to do. I'm going to go back to my VM. And in fact, in the VM, I put a link. In the VM, I put a link to this file with all of the commands in. So there we go. So what we're doing here is we're going to use curl to hit this crt.sh. It's not really an API. I mean, it's not an API in the sense that it doesn't have a contract, but actually on this particular one with this query, if you put output JSON as a parameter, then it will send you some JSON. And then so we can filter on the JSON with JQ, and we can get a list of certificate IDs, and then we can stick those certificate IDs in a file. So let me just run that. So what this is doing now, it's crt.sh. Let me just show you what that looks like in case you've never seen it before. So crt.sh is a service provided by Sectigo. Sectigo used to be known as Komodo. I think they're trying to purge their sins of the past by providing this for free, because they nearly got kicked out of like the root browser stores of, the root certificate stores of all the browsers because they were doing a bad job. But now they're the ones that are providing this for free. Why is that not working? Is the Wi-Fi good here? No? Okay. I'll maybe switch to my phone if need be. Right. So this is what crt.sh looks like. There's virtually no documentation. There's a couple of pages you can go to. You can put a domain name. In fact, it should be google.com. Thank you. You can put a domain name in here, and yeah, that's slow. Let me just. I'm just going to switch to my phone. Okay. Let's just see if that works better. Okay. It's a bit faster with the Wi-Fi. So you can see here what you've got is a list of certificates that have been emitted in the last few months for these different domain names. You've got the start of the validity, the end of the validity of the certificate, and you've got an ID. And if you've got the ID, then you can get all the other data that is on this certificate, including stuff like the organization name, the subject organization name. So that's what we're trying to do here. We're trying to get this subject organization name, but for our organization, jackdaniels.com. So what I've got here now is a list of certificates, and what I want to do is query for each one of those IDs and say, is there a subject organization name associated with it? So let's go back. So the next, yeah, that's just counting how many there are. So in the PDF file, in this text file, let me just see. Yeah, in the PDF is a link. That first link is the text file that I'm using in the VM. So what we've got here is a little bash loop. There are loads of these. It's great to kind of get in the habit of doing this because you can just make your life so much easier. So what I'm doing here is saying, okay, read the file that I've just produced. So this is the file crt.sh ID. So, and for the file, for that each line, turn it into a variable ID, and then do a curl request to this URL. That will just spit out some HTML. So there's no API. The output JSON that worked on the previous one, it doesn't work here. And so if I, well, let me just show you what it looks like. Sorry. So if I just run that like that, we'll get some results, but we're just going to get, he says, okay, right. So we're going to get some HTML. It's going to look like this, and we're going to get one HTML page per certificate, okay? It's a bit slow. It just is what it is. Can't do anything about that. So the sed command here just strips out these, replaces these non-breaking space characters with actual spaces. And then Perl, why Perl? Because actually, if you're going to do extended regex, Perl is kind of one of the nicest ways of doing that. And what this will do is actually spit out just these characters. So it's a regex, and it will match organization names. So I'm going to run that. Are people able to follow? Is anyone able to get this far? Doing it on who's doing it on this same organization on Jack Daniels? Yeah, a few, and who's doing it on a different organization? Just so I know. Okay, thank you. So a few things about certificates. This is just going to run in the background, and we'll start getting some answers. Hopefully, it's just too slow. In the last few years, Let's Encrypt has kind of screwed around a bit with our process because a lot of organizations moved to Let's Encrypt, and so they've stopped filling in a form, and so they've stopped typing in the organization name. But for the moment, is still a good technique because we can use the historical data, and a lot of big organizations or medium-sized organizations, they might have, let's encrypt on like their primary domains, or but then they've still got certificates that are valid for 2 years on other domains. This is just too slow. What can we do? Well, I'm just going to let that run, and I'm going to carry on with the next, explaining what we're going to do next, and then hopefully we'll get some results while that's doing. Okay. There's also a tool called crt.sh, so you can do a git clone of this tool now. And see, this is just a bash shell wrapper for various APIs on that same website that we've just looked at. And one of the things, so we could have used this from the start, but I wanted to just start off with curl and the actual website just to build up to it. So this crt.sh tool has got a cool feature, which is that you can pass a subject organization as a parameter. So Brown-Forman is actually the name of the company that owns Jack Daniels. If I go back to my VM here, if I started getting... I'm going to need a beer. This is not slow in the sense that we're hitting these this curl, this website, and we're passing one parameter, and we're getting a web page back that looks like this. There's no images. It should be fast. It should just be pumping through these. I'm a bit confused. Let me just see how many of the certificates we've actually got here. What's the name of that file? Sorry. CERT. Okay, so there's 57 HTML requests. Should be done already. Right. I'm just going to run it. I don't understand why I'm getting no results at all. 57 requests. Oh, no, yeah, because it's the same as this, right? I mean, I can take one of these values, random. I can stick it in here. And I get an answer immediately, and you can see organization name Brown-Forman, right? So I don't understand why. Let me just go back, check my my bash. Okay. And it's the search in home directory. Let's just try again. I don't understand why it's taking time. I know what I'm going to do to make this go quicker. Right. So we've got 57 lines. I'm just going to I'm going to kill the first 30 lines of this file because it's basically this organization has actually got a bunch of certificates with Cloudflare in their subject organization name. And then it's got some of the later certificates. They've got Brown-Forman and Brown-Forman organization. Okay. Right. We're just going to continue. I'm going to leave that running in the background. I don't think there's anything wrong with it. I think it will give us an answer. For some reason that I can't really work out right now, it's just running slowly, but we'll carry on. We've got in this crt.sh tool, and we're going to carry on as if we just got the results, and then we'll come back to that, and hopefully we're going to be we're not going to be bothered by this kind of problem in the future. So I've got two subject organization names that come out of that first section: Brown-Forman, space corporation, and Brown-Forman. So we can run these two commands, and we replace the space. With. Sorry, getting stressed now. We replace the space with a plus symbol. Just seeing how terrible this is. Yeah, no, it's just. Okay, I'm going to switch back to the Wi-Fi. This is. Yeah, well, this is 5G as well. I just let me see if that's any better. Okay, that's working. Okay, this worked. Okay, I'll go back. Okay, let me just. I'm going to screw up my process by. I'll come back to you with the offer of 5G if this Wi-Fi just. Okay. So we've done this this first domain name, Brown-Forman Corporation. Sorry, first subject organization. I'm going to do the second one here. You can see we've got 8 FQDNs or subdomains. And what we're really interested in at this stage is the top-level domains. So bf.com, bf apps, bf online, and so forth. Okay. It's weird because, okay. Okay, this is our problem. Because I've just switched to the Wi-Fi and you're all on the Wi-Fi and you're, so, okay. Okay. You know what? We'll just live with it. We'll just deal with it and can I have your Wi-Fi password, please? This one?
Yes.
you want to come and type it in? Sorry? Do you want to type it in, or do you want to tell everyone? It says CERT. Just watch out. Thank you.
Does it work?
Yeah. Thank you. You're a lifesaver. Okay, we're back. That's wrong, so I'm going to run it again. Okay, that's good. I like your phone. Okay, so we've run, we've done these two commands. We've got a list of FQDNs by pivoting on subject organization names. The next stage is to parse out the top level domains. So when I was writing this, there are lots of libraries that exist, but there was no really basic tool to do this. So I created this one. It's about as simple as you can get, and it's kind of ugly, but it really just, it just is no nonsense, basically. So you can send this tool any domain name, URL, FQDN, IP address, and it will send you the list of top-level domains. So, and it will handle either as an argument, either a file or standard in, or you can pipe to it as well. So if you pull down this tool, the easiest thing, hang on. So the easiest thing is to take parsedomains.python, make it executable, and put it in whatever directory you're working in here. And the idea is, and let me just, the idea is that we can take output from crt.sh, send it to this Python script, and what we'll get out is just the top-level domains. Hang on. Okay. I'm still doing this. I'm going back to my host instead of... Sorry. I need to go here. Okay, so I'll show you for like this. Okay. So yeah, we just sent it a bunch of FQDNs, and we've got the top-level domains, and now all we need to do is just do a unique sort on here. And now what we've got is a list of domains, and we're going to stick that in a file and call it domains1.txt. Okay. And we've got 8, is that right? 1, 2, 3, 4, 5, 6, 7, 8. Yeah. And because we pivoted on subject organization name, at this stage, 0 false positives. Because, unless the subject organization name is like 4 letters, if you take a subject organization name like FBI, then you're going to have false positives. A lot. Cyber criminals particularly like to put FBI in their subject organization name. Could be a useful way of finding malicious domains, in fact. So we've got our TL, our top level, our first level domains here. If there are any false positives, we could remove them. But this is looking pretty good. Let me just go back. Yeah. Sometimes it's really obvious, like Cloudflare. When you're not sure, Whois is quite a good tool. And if you're outside Europe, then you can get useful information. If you're in Europe, then it's useless. GDPR to thank for that. So what we're going to do next is, well, I'll show you the Whois. It's in the documentation. So here's a domain. This Woodford Reserve Mint Julep.com. Is it actually a domain to do with this organization. If you just grep for Brown, you can see that the registrant organization field is Brown Foreman Corporation. So we know it is them. Okay. Next step. Are there any other organization names? So I'm not actually going to do this, but it is a useful step. We've got a list of 8 domain names. You can do a Whois for those domain names, and then grep out the registrant organization fields like I just did here. Okay? And often, because like I said, this is process driven, at some point there's been like a company process or a company standard to say, when you put our name in a form, it should be like this, PepsiCo colon, PepsiCo comma limited or whatever it is. And so by using this, by just iterating through the domain names and doing a Whois and getting the registrant organization, then you can get other subject organization names you can try pivoting on. And it's because in the real world, at some point, someone's going to make a mistake. They're going to add an extra, they're going to do it without spaces. So corporation would be directly stuck onto Brown Foreman. And that might help you find some additional domains. We can actually just try that now, right? We can, sorry. Probably it's not going to give anything, but it's worth a try, right? Okay. And you could also do Brown Foreman without a dash. Okay. So their processes are pretty good. So using Whois to get additional organization names. Now that we've got a list of domains, we're going to get all of the FQDNs for that list of domains from crt.sh. Okay? So if I go back here, we're just going to go back into crt.sh. We've got a list of domains that I've called, on this machine, I've called domains1.txt. And so I'm going to do another little bash loop. I'm going to read each line of this file, and I'm going to call crt.sh with the domain parameter and send the content. And I'm going to do a sleep 1 to try and avoid hitting the API limiter on crt.sh, which is what was happening before. You can do with crt.sh, you can do 60 requests a minute per API. Sorry, per IP address. So by putting a sleep 1 in there, you're never going to, you can leave it running for hours and you're not going to hit that limit. But if you're on the Wi-Fi, then it's not going to work. Okay. So what we've got now is we've got an output file, an output directory. For each domain, we've got a file with domain, and for each subject organization we tried, we've got a file, and those files are full of FQDNs. So if I take this one, Jack lives here. There we go. We've got 4. It's always good to have a look at these files, because if you get one with like tens of thousands of FQDNs in, it's probably a false positive. It's one way of identifying false positives in your results. If they're too big, then it's suspicious. Okay. The next stage is to really iterate. So we've got FQDNs. for all of these domains. And because you can have certificates with multiple, with subject alternative names, there can be new first-level domains in these files that aren't in our domains1.txt file. So we're now going to go through these files and get any first-level domains that we don't already have. Okay. So what I'm doing here is concatenating all of the crt.sh output files, sticking them back through parse domains, sorting the list, and sticking it in a new file. So I'm just going to call it domains2. That's what's in my slides. Sorry, I'm just in here. I should be here. Okay. So we've got a bunch of additional domains, some obvious false positives, some other stuff. I mean, educational. I kind of wonder how you get to universities from whiskey, but, you know, possibly that makes sense. So let's just clear up this list. I'm going to remove this Cloudflare. Chambord Chanel, I'm not sure. Cooper's Craft, that's definitely whiskey-esque. This one, false positive. Early Times, I'm not sure. Exact Target, that's a marketing thing. So if you're doing this on a regular basis, build yourself a list of known false positives of, you know, Cloudflare SSL, Azure, Amazon AWS.com, and so on. And then you can just filter out those as you go along. I'm going to go for this one. So I know that wholewhale.com is also a false positive. It's a digital agency. I mean, the other way you can do this is obviously not passive, going to a domain like this. But, you know, you can see digital agency, so it's not in scope. EDU is not going to be in scope either. Okay, so we've got some where we're not sure. So earlytimes.com, let's try the Whois technique. So what I'm looking for is the registrant organization, and here it's domains by proxy. So this is you know, the kind of problem when you're trying to scope out an organization. Is this actually part of, you know, part of Brown-Forman or not? Let's just go to the website. You know, I don't have a problem with. Okay, it's whiskey related. It's in scope. Am I over 21? No. Okay. Right. What else did we have we weren't sure about? So this one, lgmador.com. Let's just try this on Whois as well. It'd be nice that one of these gave us an actual useful answer. Let's have a look. Yes. So there we go. Registrant organization, Brown-Forman Corporation, right? So we know that that's in scope. Okay, there's my list of domains. And how many have we got now? So actually we got 17 in there, and maybe there's some overlap. So what we can do is, no, that's not what I wanted to do. This is what I want to do. So we're going to use com. It's kind of, I think it's quite unknown little tool, but basically it allows you to compare a file. And by default, if you provide it 2 file names, it will spit out 3 columns. First column, lines that are in first file. Second column, lines that are in the second file. And third column, lines that are in both files. And then you can suppress columns. So if I do com -13, this file, and then this file, what I will get is lines that are only in the second file, right? Let me just show you what it looks like. So if I do domains 1, domains 2, so what this is saying is that, so column 1 is empty. So we actually, we basically domains 2 has duplicates from domains 1. These ones here are only in domains 2, and all of these are in both domains 1 and domain 2. So by doing com minus 13, then we can get the domains that are only in domains2.txt. And I'm going to just create a file 2b, and I'm going to remove domains 2. That's just so that sorry. Okay. It's just so that I can actually know that I've not got duplicates in those files. And I kind of put this little things in the process just so they're tools that can be helpful for you. Thanks, Sylvain. It could be helpful. Right. Okay. So what we've got now is we've kind of been through this CTL phase, and we're going to concatenate those domain names and put them in a file. So domains 1 txt, domains 2b txt, and we're going to stick them in domains ctl.txt. Okay, so this gives us a base to go forwards of 17 first level domains. What we're going to do next is go into passive DNS. So if I go back to our original process, we've used certificate transparency logs, we pivoted on subject organization name, and what we're going to do next is some various passive DNS tools. So Subfinder is pretty powerful. You can do a git clone. The thing about Subfinder is this. Let's just have a look at this a second. Yeah, Subfinder needs Go, and it needs at least version 121. So this is a bit of an annoying dependency. If you don't have a working Go environment, you're going to have to go to the Go installation page. It's quite straightforward. You just have to download the Go tarball, untar it, add the path into your profile, so it will find the Go binary, and then you can install Subfinder using this command. Okay. This was why I bothered with VMs and stuff, just to save you this pain. Okay. So what we're going to do is look at if you just run Subfinder with -L. Or -ls, I think. It will spit out the list of all the different. These are all the different services that Subfinder will query. Okay, and so with our list of first level domain names, we can query all of these services. Now, if they've got a star, then you need an API key. Some of them are commercial, some of them are free, but you're still going to have to sign up for them all. So for today, we're just going to stick with the ones that are free, basically. So if we look at the list of all those that don't have a star, what have we got? Alien Vault, Anubis, Common Crawl, crt.sh again, Digitaurus, DNS Dumpster, HyperTarget, Rapid DNS, Site Dossier, and Wayback Archive. So we're going to query all of those services now, and we can just pass in the file that we've just created. Oh yeah, we need to create a directory to put all the data in. So output subfinder and my file is called domains ctl.txt. Right. So, I mean, again, we're going to have the problem for the workshop if you're all going to be hitting these APIs on the same IP address. It's actually relatively quick. I mean, I'm going to leave it running in the background, and we're going to look at some other stuff. But when I tested this earlier on just a standard home internet connection, it had for 17 domains in about five minutes. Then it's finished. So it's going to create output files for all of those domains. We're just going to leave that running. Okay, so that's Subfinder. Another thing we can query is DNS Dumpster. Although DNS Dumpster was in that list, we can actually get some more useful information from DNS Dumpster for the next part of the process. DNS Dumpster allows you to do 50 requests a day from the same IP address. It doesn't have any other kind of contract. I mean, you can sign up for a paid service, but yeah, in normal times you can use your IP address to do 50 requests a day. What I'm going to do here is, what you have to do is you have to get a CSRF token, and then you can call DNS Dumpster. You can provide a domain variable is in this target IP field, and then it's going to spit out HTML, and we're going to pass that HTML to find the things that are interesting. So I apologize if you can't follow this because your IP address is already going to be saturated with other requests, but hopefully you can follow anyway. So let's go down here. So I'm going to create a directory again. So DNS Dumpster. Okay. And we're going to, what are we going to do? We're going to, first of all, get this CRSF token. So this is just making one connection to dnsdumpster.com. We're going to get a cookie, and we're going to strip out this token so that we send back that cookie with our subsequent requests. Okay, what does that look like? CRSF token, CSRF. Okay, so we've got our token, and now we can send that back with our subsequent requests. And I'm going to send back that same list of 17 domains, and we're going to get for each domain, we're going to stick a file with the HTML content in this output directory, which to make my life more complicated, I've given a different name again. So, okay, let's just fix this. Dumpster. And this one's called domains CTO. Okay, I think we're good. So why bother with DNS Dumpster when this is already querying DNS Dumpster? It's just that DNS Dumpster also lists all of the ASs for each associated with each domain name. It lists things like MX records, and so you can also get the IP addresses and the hosting companies for the MX records. It shows things like SPF. So it's showing a whole bunch of other passive DNS data that that this is not going to find. This is just pulling back FQDNs, basically. And by doing this, we're going to get a bunch more information. And obviously, you could do this manually. You could go onto DNS Dumpster. You could go on here and do it manually, if you. But with this process, I was trying to suggest a way of being able to do it in a repeatable way with, massive amounts. I mean, you can do this with hundreds of domain names. If you're doing hundreds of domain names and you've not got a license for paid license for DNS Dumpster, then you can do it over 2 24-hour periods, 50 domains each day, and that works fine. Okay. We've finished our, so our subfinder is finished. So if we go into output subfinder, what's in there? So again, let's look at the TXT files and check that there are none that are massive, basically. So jackdaniels.com is the biggest one here. That all makes sense. But if we'd got a false positive that was associated with a hosting company or a telco, then we could have thousands of FQDNs, and it kind of is just really obvious. Right. And let's just go back to here. I'm going to leave this one running now. If we just have a look in there, DNS Dumpster. Yeah, it's running, right? It's not super fast, but it's getting through them. It's going to finish in the next minute or so. So we've got these HTML files. If you want to look, what are we actually seeing here? bf.com.txt. So we've actually got a raw HTML file. I mean, we could open this up in Firefox and look at it, but you've got tables with all this kind of data, DNS servers, MX records, TXT records. There's all sorts of useful stuff in there. And so the question was, well, how do we take a bunch of files like that and in a industrial way just strip out everything that's interesting? So what I've got to do that is a little tool. IOC extract is a tool used often by CERT teams. If you've got a PDF file, this was the idea originally. If you've got a PDF file or an HTTP report or something, you can feed it to IOC extract. It's a little Python tool, and by default, it will just spit out a list of anything that looks like a URL or an IP address. So I'm basically abusing a blue teamer's tool to parse this DNS data, this DNS dumpster output. And so IOC extract is going to give us a list of links. And if we look in the TXT file that we were just looking in, yeah, you can see that there's loads of links to API-hackertarget.com, and then a query string, and then an IP address, or a query string, and then a domain name. And so what we're going to do is we're going to IOC extract is going to spit out that, And what we want is just the IP address, right? So what we're going to do is we're going to use awk. We're going to pull out, use q equals as our separator. So IOC extract is just going to give us a list of URLs. Awk is going to give us the right-hand column. And then sed is just going to remove, if it's there, is remove the HTTP scheme. And so what will give us at the end here is a list of URLs, of FQDNs, and then and IP addresses. And then we've got a little grep here, which, okay, it's not. If you want to, you can find. I think there's currently 20 different regexes to identify IP addresses. There's so many different ways of doing it. This is a really basic one, but IOC extract has already done the hard work for us. So we're just anything that looks like an IP address, we want to get rid of. And so the V here gets rid of anything that matches. And so what's left is our host names. Let's have a look at that. What does it look like when it's running? So DNS Dumpster is done now. So we've got a file for each domain. Some of them have come back with no results, but others have got some stuff. So we're going to do this big long command, and I need to go out of that directory. Okay, so concatenate everything in DNS Dumpster.txt. Pass it to IOC extract. Awk for query strings. Strip out any HTTP. Sort it in a list, and then dump anything that matches as an IP address, and stick it in a file called hostnames3.txt. I mean, it's a monster, it's a horrendous command line, but it makes sense if you go through it step by step. It makes sense, and have a play with IOC extract. It's just a really good way of getting useful data out of bulk data or HTML pages and things like that. MacBook keyboard. Right. Just it's the kind of stuff you can do, right? It's also got options for, managing the output and input. You can see it's designed for blue teams. Okay. This is still running. My VM is churning away. If we had more time, I'd show you the different steps here, but we're not going to get to the end otherwise. Okay. Right. So we've now got a bunch of domain names. Sorry, a bunch of FQDNs. Define my terms and then don't use them. A bunch of FQDNs. What we're going to do is we're going to use okay. I think I've skipped a step here. Basically, what we would need to do is take those host names and then put them back through past domains, so that you can see, are there any new actual first-level domains in there. And you can see a bunch of false positives. Yeah, there's no new first-level domains. Brainsway, I think we already had that one. Anyway, let me get back to the script. So, oh yeah, so we can run exactly the same command, but just by removing the v, then we get all the IP addresses. So we're going to do that. So we're going to run the same command, and we're going to this time put them in a file called ip1.txt, and we're just going to remove the v. It's the same data, but we're just taking the IPs instead of the FQDNs. Okay. What are we going to do with the IP addresses? I'm confused. I did it the other way around in my slides. Sorry. Okay. Oh, no. No. Shit. Okay. So IP addresses. So what we're doing next is going back to the DNS Dumpster data, but we're looking for autonomous system names. I tested this morning. This still works, but it might break. So I'm just basically parsing out, looking for this bit of HTML, and that happens to contain the autonomous system names. Yeah, if they change their web page, it's going to stop working. But I've not found a better way of doing this, because autonomous system name is just a bit of text. So there's no other way of identifying it, really. So let's go here, and let's see what that gives us. So again, this is why we're using DNS Dumpster, is to get this kind of data. Dumpster. Okay. So those are all of the autonomous system names in that DNS Dumpster data. A lot of stuff you would expect: Salesforce, Google Cloud Platform, Fastly. What we've got here is BF, right? Brown-Forman. This is the stage, where a human needs to be in the process, because, it's very difficult to identify this kind of data programmatically. How do we know that BF is Brown-Forman? I mean, as humans, we know instinctively it is, but how to write a script or train an LLM model to figure that out is probably quite difficult. So we've got an autonomous system name. What we're now going to do is explore the IP and netname data. And so we're going to start with hacker target. And so we're going to use curl again, and we're going to hit this API with the autonomous system name as our parameter. Tick. Okay. So I'm just using this text string which came out of this DNS Dumpster data. And what I've got now is a bunch of matching ASs, but we've got this one here with the number 40,338. And I've deliberately, the next few steps, I've deliberately used different tools. So hacker target is one, BGP view is another. So now we're going to use BGP view to get a list of subnets or netblocks associated with this ASN. So BGP view, we're going to use curl again, and we've already got our little a bit of Perl to pull out the net block from the data. Okay. So So you can see the ASN number is just passed to BGP view in the URL. And we're asking it for the prefixes. And then, what's going on here? Okay, that'll do. And I'm going to put it in a file called IP2. What does that look like? Yeah, perfect. So we've got a net block. So just a reminder, we started off with one domain name, jackdaniels.com. So far we've got 17 first-level domains. We don't quite know yet how many potential host names we have, but we've also got a net block by using DNS. So by using DNS Dumpster, searching each domain name, and then searching through that data for autonomous system names. And we've gone from there through the autonomous system number to get an IP, a net block, so a subnet. Right, next thing, Geolocus. What you can do with Geolocus, so Geolocus is a free geolocation and netblock API. It's ONYPHE that provides it. You can go and have a look and play with it. It's unlimited. You can. It's totally free. Is it IO? I think so. So you can put in an IP address. You can put in well, have a look around with it. So we've basically built a geolocation database using Whois data. So it's probably not as accurate as MaxMind. It's based on what companies are putting in when they register a subnet in Whois. Then they put in an address, and that's what we're using to build this. So, but it's got some kind of useful other use cases. So what we can do is we can take that list of IP addresses from DNS Dumpster. So we had in our IP1 file, we had 123 IP addresses, and we can send all of those to Geolocus, and we can say, are there any other autonomous systems which might be associated with with that organization? So if I take this, it's going to spit out some Java, some JSON. Let's just, what I'm going to do is just take up to here. So you can just see what Geolocus is sending back. What have I done wrong? What's the file name that's wrong? It's ip1.txt. Okay. Yeah. So we're just getting some. Now this is kind of useful because you can see that there are other net ranges here where the name of the network is Brown Foreman, but and this is on an AS which belongs to AT&T. But when AT&T have registered that net block in Whois, they've put the name of their customer in the Whois data, so we can now identify those, right? So otherwise we would have missed that that net block because, it doesn't, the AS name is AT&T Services Inc., but the net name in Whois is Brown FO448. So if I go back to my sed command here, that's going to strip out all of the done it again. So this is just removing the extra characters and Did I just screw that up? No. Oh, it's because there's a sort. So because there's a unique sort here, it's buffering. It's we're just going to have some beer. Yeah. Okay. So now we've got our nice tidy list, and we're going to use eyeball technology to go down this list and identify stuff that might be interesting to us. And here's another subnet range that concerns Brown-Forman that we didn't have before. So let's stick that in our IP2 TXT file. Oh, is it the same one? Ah, it's the same one. Shit. Oh, well. But still, you get the idea. Right. Final step is just showing reverse DNS lookup. So we've got a list of IP addresses. ONYPHE can... so I don't know if you've never seen ONYPHE before. Looks like this. We have a bunch of... I'm logged in with a Freeview account. So I've basically put an API key in the PDF file. So you can put that, you can basically install the ONYPHE client for tonight until tomorrow morning. You can mess around with this if you want. If you install the ONYPHE client and you pass the API key as a parameter to this installed shell script here. And we have a bunch of different categories of data, but one of them is resolver. We do about 2 billion DNS lookups each month, and we keep the history for 12 months. So we've got our own passive DNS database, and you can search both ways. So we've got a list of 120 IP addresses, and we can ask ONYPHE, well, are there any FQDNs that match these IP addresses? So that's what we're going to do. We're going to hit our search API. We're going to specify the resolver category. We're going to provide a list of 120 IP addresses, and we're going to say, give us any host names in that data. So what does that look like actually on a... if I show you what it looks like here, category resolver IP, right? If I put in an IP address, then what you get here is a bunch of JSON documents, and for each JSON document you have the timestamp and the host name, and so when we do this API call, we're going to get a document like this for each IP address, and then we can just pass out the host name. So these are each time that we've hit an FQDN that's resolved to 1.1.1.1, then we store it in. So that one makes sense. This is a bit weird. Why is company making their web server resolve to 1.1.1.1? It's the internet. It's weird. So let me just check that this is set up on here. So ONYPHE, no, okay. So I need to put my API key in there. Just bear with me a second. How am I going to do this? You know what I'm going to do? I'm just going to use my... is the API key in your PDF document? It's just me that doesn't have it, right? Hang on. I'm just going to get it from here. Has everyone got the API key or not? No answer. Okay, I'm just going to do this on my MacBook as because it will You've got the API key, okay. Just bear with me a second. I need to get this API key in here. I thought I'd done this already, but this is not going to work, is it? Virtual machine, sync key. No. Just bear with me. I'll get there. This is what I need. Z08 EFW SCT. Z08 EFW. Z08 EFW. Okay. There he is. What? Oh, shit. I don't know, the browser's doing some weird stuff. Right. Okay. Okay, so we're going to do this request. I'm going to go, first of all, we're going to do it with curl. So there is also an ONYPHE client. It's Perl based, so it requires quite a lot of dependencies, but it's very powerful. So hang on, my command line's messed up. Just bear with me. Okay, I think we're good now. No. What's not working? Oh, why is there a point vacant there? That shouldn't be there. Content authorization, xget, that looks good. Okay, right. No. Crap. Oh, it's because I'm pasting from. I need to just use this. It'll be copying and pasting from presentation doesn't work. Right. Okay, I'll get there in the end. So for all of those 120 IP addresses, we're going to hit the ONYPHE API. The API key has got about 1 million results, so 1 million results available for tonight, so it should work for anyone who wants to try it. So we're querying all of those. While that's running, I'm going to show you that we can do the same thing with the ONYPHE API, with the ONYPHE command line tool. Oh yeah, you can also So with enterprise license, you can just stick in a CIDR network and do a CIDR search. With the Freeview licenses, you can't do that. So you would need to iterate over the IP range like that and get any host names that match that subnet that we had. The ONYPHE command line. Here we did it with this curl command, but on this page it's the same thing with the ONYPHE command line. ONYPHE basically has its own query language, which is based on Lucene. And so you have categories. So data scan is it's like Shodan. So if you put in an IP address, you'll get the open ports and services on that IP address. So an HTTP service, and you get the raw data from the service, and you get some other information like TLS certificate. And the resolver category we're just looking at. Let me just come back to my VM. Okay, that's finished now. So just to wrap up, we had what you've now got is we've got some files here that are hang on a second. Yeah, I realize I'm out of time. No, just one second. So the final step would be now to go through those different documents, but to give you just to give us an idea, if we say, okay, all host names txt, there we go, and then output subfinder star.txt and crt.sh output. We'll just take all of those. Oops, sorry, deck. And let's just let's sort them. This will be the last thing. Sort-u, and then we're going to count them. So this will give us a rough idea of how many FQDNs we've actually. So we've identified 700 FQDNs starting from one domain name. So I know it's been a bit painful with the internet problems, and I was a bit thrown off balance at the start. But I think you can see this process is pretty powerful, and with the hopefully the different tools and the approaches that I've shown with you will be helpful when you're doing this. Yeah, 700 FQDNs is pretty good. So thank you very much.
Do you want to take some questions or not?
Sure, yeah, if people want.
I don't understand the password for the VM.
Oh. Yeah, you could have interrupted me. It's ONYPHE lowercase. I'll type it in. It looks like this. ONYPHE lowercase. Sorry. Yeah, so yeah, the VM is free. It's got all those tools installed. Feel free to use that as much as you want. It's just a standard Ubuntu.
Thanks.
Nothing weird. Yeah, you're welcome.
Other questions? Feel free. Nope.
Thank you for your patience. Oh, there's a question over there.
Oh, sorry.
Just one question regarding the not passive one, the last part.
Oh yeah, the not passive. Yeah, sure. So
it's just regarding the authorization. Like, do we need the authorization of our company, for example, to do that?
No. So this is just going to hit DNS resolvers. So Subroot has got a hard-coded list of known host names. So it's really useful for finding like technical stuff, like Kerberos service host names. It's got stuff, basic stuff like VPN, mail, all of those things. It's not passive in the sense that it's going to do active DNS resolutions. Everything else we've saw, all those other services, is totally passive. So if you're doing a red team exercise, you can do all that, and you're pretty safe. But the resolvers are going to start sending out DNS queries. So if the blue team have put canaries in there, then this could trigger the canaries. So yeah.
Any other questions or not? Nope. Thank you very much, sir.
Thank you.